So Kevin just gave me a very nice intro about Ethereum usability and standards. And so I, as indicated, am co-founder and product lead of Viewport, a self-sovereign identity platform built on Ethereum. And it's basically, what we've built is a way, a user-friendly way for the normal people, normal end users, to manage their private keys. We use the mobile phone to do this. We built a whole underlying platform, which I'll talk about. And hopefully at the end of this presentation, you'll understand a bit more about what we're doing and how it will make bringing users to your dApps a lot easier. And so it's been a lot of development effort with Ethereum over the last year or two. But where are the dApps? Where are the things I can use besides cryptocurrencies today? All of the things that everyone else is building are sort of predicated upon the expectation that Ethereum will be usable and it will be easy for normal people to create accounts, sign transactions, understand gas, and everything else. And so Viewport makes Ethereum easy. What we've built is a mobile application, a mobile key vault that stores your private keys, your identities, your accounts, the private keys that control your accounts, and badges and other data about yourself. We'll just go a bit more into each of these. Okay, there is other stuff on this slide. It's just not so Viewport uses a smart contract identity model, meaning that we store private keys. This is a smartphone here. We store private keys on the mobile in the secure enclave on the mobile application. Those private keys control an account registered on any Ethereum blockchain. And it's through that account, that smart contract, that you interact with application contracts. So the mobile phone receives some data from a front end of an application, like buy shares or do transaction or buy kitties. And what happens is the application will generate an Ethereum transaction and send it to the Viewport mobile application for signing and approval. And once it arrives in the mobile app, the user sees a little friendly card, clicks approve, signs it, and sends it back to the network. Okay, good. And what we've learned is that users have many accounts on many networks, so managing private keys isn't all that easy. And so what we've built is a multi-chain account architecture. So on all of the major Ethereum networks, we've deployed our infrastructure, our identity factory contracts, smart contracts that create other smart contracts, which are identities. And so we deploy this infrastructure on every Ethereum network. And what happens is, a user just goes to log into any application like they normally would today with their Viewport app. So let's say I go to a certain application on the test net and I click login. And what happens is that application will send a request to my Viewport app and say, a user is trying to log into my service. Does this user have an account for my service on this network? And so if true, then the user will just send their address into the account for that network to the app, and the app will authenticate them. The user will sign a challenge on the mobile. If they don't have that account, then our platform will create one for them in the background. So what we're doing is we're managing keys to your Ethereum accounts on all of your networks on the phone. And we're creating accounts we're creating application-specific accounts, so pairwise accounts. And what that does is it improves the privacy profile of Ethereum accounts. It takes the user's thought process out of it, and it maintains one-to-one relationships between a user and that application. So if I'm on Gnosis, buying prediction market tokens, I log into Gnosis with my Gnosis account. All of the transactions I do on Gnosis are attributed to my Gnosis account. Then let's say I go to Kyber or any other platform and I log in and do transactions on their platform. I use a different account for that, and so the people that are looking at me on Kyber, the ones that I'm interacting with there, don't know my history and reputation from Gnosis unless I choose to publish that to them. But because our platform is smartly managing accounts for users in the background of our app, people don't have to think about it. And so we can help improve the privacy profile of Ethereum. We also learned that users want one platform for all of their interactions, regardless of where app logic is run. So what we've seen over the last year is the rise of hybrid applications, that is, applications that aren't purely smart contract based. We've actually seen that most of the applications in development today have some element of smart contract logic where certain core infrastructure is run. We see decentralization of user platform or private keys. But we see that these applications are also running servers to authenticate users, or they're running servers to handle non-core business logic. They're running databases to store user data. And so we're actually seeing one application where users are forced to now use one application to log in, another application to sign transactions, another one maybe to send ether. And so we bring all of that under one hood for the user. And this is sort of the world that we're working towards. There's also more stuff here. And so with this central point of managing users' keys, where it's all on their device, now it doesn't matter if I'm authenticating to a web server or I'm sending a signed transaction back to the Ethereum network or any other blockchain network. Our phone abstracts that nicely, or our platform abstracts that nicely on the user's mobile phone. So they receive some data, some request, they sign it, and send it back regardless of where the destination is. We've also learned that users want to use the applications themselves. They don't want to worry about networks or gas or managing their own privacy. And so we built a smarter login flow, the things I talked about before. So a user goes to an app, clicks login. Doesn't matter if that app is running on Rinkeby, Dropston, Mainnet, wherever, the user is able to log in. If they have the right account, they'll be logged in with that correct account. If they don't, we'll create one. Again, this is great for managing privacy, and we're doing it for the users so they don't have to think about it. Also, gas. Like Kevin said, gas is a huge barrier to entry for normal people. Using a dApp today requires going to an exchange or some other means of acquiring ether to create your contracts, to pay for your gas, to even onboard to the application. So now as a developer, you have to worry about getting users to your app and then bringing them through that process of acquiring ether and onboarding. We make it easier because in the Newport platform, we built a service called SenSuite. And SenSuite is basically a gas station that pays for users' transactions, the gas for the transactions in the background, so they don't have to worry about any UI. Users don't have to go acquire ether to create accounts now, so just pay for it in the background. Users don't have to worry about changing gas notes and prices on every transaction and dealing with all of that visual noise that they know nothing about because it's in the background. And so there are two ways in the future that this will evolve. Today, we Uport pay for all transactions on our network. In the future, we'll be decentralizing this service even more so that application developers will be paying for the transactions of gas that interact with their application smart contracts. And then thirdly, I think there's an EIP for contracts to pay for their own gas. So this is decentralizing itself, but the key is we're hiding all of this from users so we don't have to worry about jumping through these hoops just to use my own. Credentials. We've also learned that developers want to issue badges and other credentials to users. You can think of it as sort of just a digitally signed statement about my identity that expresses some fact about it. So, issuing badges to users. You can imagine a flow where a user logs into my site, does something, maybe performs their 100th transaction or breeds their 5th kitty, and my site, my server, generates a credential, digitally signs it, and sends it to a user. Once the user has it, they store it on their mobile app. And so developers want to request credentials held by users. So now, if users are managing this little database of their own private credentials on their mobile app, how do I use data issued by other services in my service? And so at Uport, we built the ability for you to request credentials. So now if a user logs into your site, let's say you're an exchange, your exchange sends a request to the Uport user saying, hey, can you share with me one of your KYC badges from one of these 5 trusted issuers? The user, who is already a customer at Coinbase, who's already connected their Uport account to their Coinbase account, has a Coinbase badge. And so the user shares that Coinbase badge with the service, who reads it, checks that the signature is valid, that the timestamp is still valid, and that since they trust Coinbase's statement that I'm KYC there, and so they don't have to KYC me themselves. And so abstracting that notion of credentials are a generalizable user-centric data structure that forms the basis for reputation systems. So now if I have a ledger of 1,000 user-centric credentials, you can imagine one or any set of algorithms can be run, and analysis can be run on those credentials, and some output can be generated. Some thing can be implied from that data, and that thing that is implied is a reputation score. We don't provide reputation scores, but we can build reputation scores on top of the platform. Lastly, mobile signatures. Users need a better way of signing transactions. So what MetaMask and what Kevin offered is signing transactions in the browser with their extension. We do it on mobile. So we store keys on mobile, and so we basically offer mobile factor authentication and blockchain signatures right there. Here we're just showing our demo with the Gnosis Olympia. And lastly, since this is about self-sovereign identity, which really is user-centric key management, where does this come to life, and where does Ethereum bridge with the real world? So we're doing that in Zoo, Switzerland, Crypto Valley. Residents of Zoo can download Import, create a self-sovereign identity on the public Ethereum blockchain, and log into the Zoo web portal, where they submit their information, such as their name and their ID number. They click submit. It gets sent to the Zoo platform in the background. Then, within 14 days, that user has to go in person to the Zoo office to have their paperwork verified in person by the clerk. The clerk verifies that the information they submit on the web portal matches the information on their paperwork they brought in person. The clerk approves them from their mobile app. What that does is it generates a credential, badge, signs it on behalf of Zoo, and sends it to the user's Zoo where it's stored. And so now, I have a digital passport from Zoo that I can use for anything. And so the use cases that they're really putting forward in the next year are, you can use this credential as an authentication token to gain access to the Zoo web portal, where you can access e-government services, and you can do things like vote. And today, it's on the opening times for a local swimming pool, but tomorrow, it'll be for government elections. That's important. Thank you.